Here's an example of given a polynomial and you're given a imaginary root that is a root of this polynomial and asks you to find all the other roots. So of course it's a fourth degree polynomial, so we know there'd be 4 roots. And since 3i is a root, that means that negative 3i is also a root. And so that's 2 of the roots. And so we can use these 2 imaginary numbers in sythetic division to knock this down to a second degree polynomial, and we can find the missing one. Okay, so let's start out with the 3i in the box, and we put 2. Now notice here in this polynomial that it goes x to the 4th and then skips to x squared. So we need to put a 0 in here because there's an x cubed missing. And then a 10, and then another 0, and then a negative 72. And a line across here. Okay, sorry I just got interrupted. So I'm going to start over here again. So we were told that 3i is a root of this function, and so we're going to run it through, and then that means negative 3i is also a root. So we're going to run through this, and notice I put in zeros to replace the missing x cubed and x. So there's a 2 times 3i is 6i, 6i plus 0 is 6i, 3i times 6i would be 18i squared. Remember I squared is negative 1, so that'd be negative 18. And negative 18 plus 10 is negative 8. 3i times negative 8 is negative 24i. Bring that down. And then 3i times negative 24i would be, that would be 3 times 24 is 72. Negative I squared. Well, I squared is negative 1, so a negative times a negative would be a positive, so that gives me 72. And that, of course, is 0. So then notice when I run negative 3i in, same thing happens. There's a 2 down there. Negative 3i times 2 is negative 6i, which gives me 0. 0 times negative 3i is 0. 0 plus 8 is negative 8. Or 0 plus negative 8 is negative 8. Negative 3i times negative 28, or negative 3i times negative 8 is positive 24i, which of course is 0. We add this together. So we're left with a 2x squared minus 8, which produces a, if we set that equal to 0, that gives me 2x squared is equal to 8, which means x squared is equal to 4, which means x is equal to negative 2 or positive 2. So we started with someone told us the imaginary root, and we were able to work through sythetic division to find the other 2. Okay, so there's one example. Let me give you one more example. So here we have y equals x to the 4th plus 4x cubed plus 4x squared minus 16x minus 32. And you're told that negative 2 plus 2i is a root, which means automatically that negative 2 minus 2i is a root. So we'll set that up, negative 2 plus 2i in the box, and 1, notice in this case there aren't any missing powers, so we just write the numbers 1, 4, 4, negative 16, negative 32. And we run that through. 1 plus nothing is 1. 1 times negative 2 plus 2i is negative 2 plus 2i. And when you're adding, you add the real to the real and the imaginary to imaginary. So there's no imaginary in 4. So 4 plus negative 2 is 2 plus 2i. And now when we multiply, I'm going to go over here to the side and show you some multiplication. This is when you have both a real and imaginary component. You treat the I like it's a variable until you get an I squared, which is negative 1. So negative 2 times 2 is negative 4. Negative 2 times 2i is negative 4i. 2i times 2 is positive 4i. And 2i times 2i is positive 4i squared. Notice the middle terms cancel out, and we're left with a negative 4, and 4i squared is the same thing as negative 4, so that becomes negative 8. So I put a negative 8 right there. Negative 8 plus 4 is negative 4. Multiply negative 4 times that, and I get 8 minus 8i. Add them, and I get negative 8 minus 8i. And if you go through this same process of multiplying negative 2 plus 2i times negative 8 minus 8i, like we did here, you end up with positive 32, and I get 0. Okay, get this out of the way. And so then I run the conjugate pair through, and notice we get negative 2 minus 2i. That's kind of nice. We get 0 there. 0 times that is 0. We get a negative 4. And that times negative 4 would be a positive 8 plus 8i. And that, of course, gives me 0. And I'm left with an x squared minus 4. Which, of course, gives me roots of 2 and negative 2. So my roots would be negative 2 plus 2i, and negative 2 minus 2i, and 2, and negative 2. Those would be all the roots.